Hello friends. Welcome to T Academy. In this video, I am going to discuss the 50 basic electrical engineering questions, so which are at diploma level and BTech level. And these questions I have collected from the various competitive exams of electrical engineering and in various states also. So the first question here it is the unit of charge. So these are the basic questions which will be useful for all your competitive exams. So this question is from HPCL AMT 2019 paper here. Okay, so unit of charge, so Q. So what is the unit of charge? It's nothing but coulomb here. Okay, so volts is a unit for voltage and ampere hour is the battery capacity. Coulomb is a charge. Coulomb is a unit of charge and ampere is a unit of current here. Okay, the answer for this question here it is. So it is a coulomb here. Okay, so next question here. So which of the following devices obey Ohm's law? So Ohm's law, what's Ohm's law? Ohm's law says that at constant temperature, the current flowing through a circuit, current flowing through a conductor is directly proportional to the potential difference applied across it. Okay, so it simply says that V is equal to R into I. Okay, and which of the following devices means rectifier, so which uses diode. Okay, so which is a non-linear device. Okay, and the arc lamp is a non-linear device. Zener diode is a non-linear device. So incandescent lamp is nothing but which is a linear device here. So answer here it is. So it is incandescent lamp is the answer here. Next question. The ratio of voltage and current in a closed circuit is. So let's take a voltage source. Okay, and there is some resistance here. Okay, it's a closed circuit here. So R, V and I. So the ratio of voltage to current in a closed circuit remains same. Why? Because resistance value remains same here. So answer for this question will be, okay, let me check. So this will be remain same here. Next one. What material swamping resistance is made up of? So swamping resistance is made up of alloy of manganese and copper here. Next, no current flows through two charged bodies if they have equal. So as we know that the current always flows from higher potential to lower potential. Okay, so higher potential to lower potential. Okay, the current will not flow if the two charged bodies will have same potential. That means the current has to flow from higher to lower or lower to higher. Okay, sorry. So current always flows from higher to lower only. Okay, so in that case the answer for this question is potential, and this question is asked in UPPCL JE 2018 paper here. So answer for the question is potential. Next, this question is asked in UGVNL 2016. The law used to find the force between two current carrying conductors. So when the current carrying conductors are placed nearby, okay, the force between these two conductors is found by Ohm's law, Lenz's law, Faraday's law, Biot-Savart's law. So correct answer for this is Biot-Savart's law. So Biot-Savart's law is the right answer. Next one, an electric current can be classified as. So this question asked in the UPRVUNAL paper. There is AE 2014 here. So the classification of currents are conduction current, displacement current, and convection current. So current is classified into three categories. The conduction current is due to potential difference, and the convection current is due to temperature rise. So when there is a temperature rise, the current is flowing here, and displacement current, you know about that. So all the above is the correct answer for this question here. Next one, 1 joule per coulomb. So this asked in the BSNL TTA 2016. So volt, ampere, farad, Gauss. Okay, the definition of voltage is work done per charge. Okay, the units of work done is nothing but W is nothing but joule here. So joules per coulomb is the voltage here. So answer for this question is units are volts. Next one, if 10 resistance of 10 ohms are connected in parallel, then the total resistance will be. So there are 10 resistances. Let me take one resistance here. Likewise, there are 10 resistors are there which are connected in parallel like this. Okay, so what will be the R equivalent here? So R equivalent is equal to, so let me take 1 by R equal to 1 by, so R1 plus 1 by R2 plus so on up to 1 by R10 here. So 10 resistors each are having how much? 10 ohms. So 1 by 10 plus like that, if you are goes on adding here, okay, so it will be equal to 1 ohm here. Or simply the shortcut is, if the same value of the resistance means 10 ohms divided by 10 resistance, nothing but 1. So answer will be 1 here. Next one, the curve representing Ohm's law. So Ohm's law is there. So we know that Ohm's law, and here we have voltage and current. So if you draw the characteristics of Ohm's law, if the voltage increases, current also increases like this. Okay, so this is a straight line passing through the origin. Okay, the curve representing Ohm's law is nothing but V is equal to R into I, which is a linear line. Okay, not a parabola. Okay, it's a straight line passing through the origin. So answer will be linear here. So answer is linear here. Okay, next one, the international ohms is equal to dash absolute ohm. So it's a direct formula here, direct value here. So one international ohm is equal to 1.00049, so which is asked in the DMRC 2016 paper. Okay, the answer will be 1.00049 is the correct answer. Next one, 1 horsepower is equal to, so this question is asked in the NPCIL 2018. So 1 HP is equal to 746 watts here. So answer is 2. Okay, now sorry, resistivity of the wire depends upon, the basic formula of resistance is equal to R is equal to rho L by A here. Don't think that is a resistance, resistivity. Okay, resistivity. So resistance means it depends upon length, area, but rho is the resistivity which depends upon the type of material. So answer for this question will be material here. Okay, if they ask resistance depends upon means you can take the length, area, okay, and material. So answer will be 3 here. And this question asked in the Uttarakhand JE 2013 paper here. So erg is a unit of measurement of, so erg is a unit of measurement of energy, and this is asked in the SSC JE 2018 paper. Okay, next question, the material which offers low resistance is known as. Okay, so here insulators, semiconductors, magnetic material, conductors. So insulator means which is having a resistance in terms of mega ohms, which opposes the current flow here. Okay, but in the given question they are asking very low resistance, so resistance value in order of milliohms, that means it is a conductor. So answer for this question will be, it's a conductor. So next question, the material which offers very high resistance. Okay, now you can tell me the answer. The answer will be insulator, just now we discussed. Okay, next one, the unit of conductance. So the unit of conductance generally denoted by G, which is a reciprocal of resistance. What is the unit of resistance? 1 by ohm, which is nothing but mho. Okay, which can also called as Siemens. So answer will be mho or Siemens. So both are correct one only. Next, the best material for a standard resistance. This is asked in the HMWS paper. So those who are having in staying in Telangana state, or those who are reading the paper in Telangana state, they know this board here. Okay, so that is a manganese here. The correct answer will be manganese. Is a correct answer. The best material for standard resistor is, okay. Next. So this question is asked in the AP Transco AE 2012 paper, right? So you can see the level of toughness of the paper. So in the 2012, 18, 17 papers, the questions will be easier. But if you see in 2019 last AP Transco paper, it's very difficult compared to that paper, right? The level of asking questions has been changed here. Okay, the question is the two incandescent bulbs of 40 watts and 60 watts are connected in what series across the main supply. Okay, now the question here is which bulbs glows brighter here. So in case of series connection, the bulb which is having a lower rating, so lower rating will glow more here. Okay, so in case of parallel means, as you know, that the higher rating bulb will glow. Okay, let's check the answer for this question. In a series connection, that is the bulb 40 watt bulb will glow brighter compared to 60 watt. So if the same question is asked, okay, in spite of series, if they ask parallel, so this is the question here, question number 20. Two incandescent lamps of 40 watts and 60 watts are connected in parallel here, parallel. Okay, so just like this. So here we have 40 watts and here we have 60 watts. Those two are connected in parallel across the supply. Then what will be the which bulb will glow clear? As we know that in home itself we can observe there are two 40 watts and 160 watts bulb, or we can say one zero bulb and one 30 watts of bulb is there. Okay, which one is glow brighter? In case of parallel connection, the rating of the bulb which is higher, which will glow here. So answer for this question is 60 watts bulb will brighter. Thevenin's equivalent circuit consisting of. So this is asked in the ESE 2009. So it is in electrical paper. What is Thevenin's equivalent? So as per Thevenin's equivalent, it says that okay, a network consisting of resistances and voltage sources can be combined together with a voltage source VTH in series with RTH here. That means the Thevenin's equivalent is representing a voltage source in series with its impedance here. So the correct answer for this question will be 1 here. Okay. Similarly, what about the Nortons? Okay, this question is asked in the ESE paper. Norton's equivalent circuit consisting of. So Norton's is a reciprocal of Thevenin's. Here, where we have a current source IN which is in parallel with the resistance here like this. Okay, so now you can guess the answer for this question. It is a current source in a parallel with its impedance here. So answer will be 4 here. Kirchhoff laws applicable to. So this is in a SAIL RSP paper 2019 they asked this question here. Kirchhoff laws applicable to both AC as well as DC networks. Okay, so in DC network what we will do is V is equal to some V1 plus V2 plus V3. Okay. Similarly, this voltage also written in terms of phasors, so it will be works for both the networks. So next question, that is the 24th question. Which of the following is a passive element in an electrical circuit? So circuit having a current source, voltage source, battery, resistor. This is asked in the SSCGE 2018 paper. So see here, the passive element means which will absorb the power. Okay, which will not able to deliver the power for a finite amount of time. Okay, so any element which can deliver some energy for a more amount of time means we can call as a active element. Okay, here voltage source is active element, current source is active element, battery also a battery is nothing but it's a voltage source. Okay, so resistor is a passive element. So answer for this question will be resistor here. So resistor, what it will do is it will dissipate the energy. It will dissipates energy in the form of heat. Okay, next, Kirchhoff voltage law is based on the law of conservation of. So just now I told you V is nothing but energy divided by Coulomb here. So V W divided by Q. So the Kirchhoff voltage law is based on the law of conservation of energy here. So it's very important and not in SSC JE. So it is asked in various JE and AE exam paper also. Okay. So answer will be what? Law of conservation of energy. Similarly, Kirchhoff current law is based on the law of conservation of charge here. Why? Because I is nothing but dq by dt here. Okay, so for this question, when the Kirchhoff current law means, it is the charge, law of conservation of charge here. Next one, a point where two or more branches connected is called as. So let me take one branch here, one branches here. There are different kinds of elements I have taken here. So this is nothing but what? This is nothing but node. Okay, a point where two or more branches connected is nothing but a node here. So this is asked in the SSC 2018 paper, right? So in this video, whatever the questions I have taken, all the questions are asked in the previous uh, exams. Okay, I am not simply taking that point and explaining here. Next question, the internal resistance of an ideal voltage source. So what is the ideal voltage source? So let me take a voltage source which having some internal resistance like this, we can call as a RS, and this is a VS. Okay, so if it is a ideal voltage source means the resistance RS should be equal to 0 here. Okay, so RS should be equal to 0. In case of voltmeter, I'm adding a voltmeter. In case of voltmeter, the RS should be equal to infinity. So I will discuss that question separately. But for now, understand the internal resistance of ideal voltage source is 0. Okay, so this question is asked in the UPPCL JE 2018. So next question here. Okay, so now the question is the internal resistance of an ideal current source is. Just now previous question we have seen there is a voltage source in series with the resistance. Now we are talking about a current source in its parallel with the resistance here. So this is the current source here. Okay, so and the resistance is nothing but RS here. So in this case the entire current has to be flow through here. Okay, there is no current, there should not be no current flow here. So in order to make the current not flow here, the RS should be equal to infinity. If you make a short circuit, the entire current will flow like this. If you make a short circuit, so to avoid this one, we make a open circuit. So open circuit means RS should be equal to infinity. So as we see the answer, that is, it is infinite. Next one, the 30th question here in the basics of electrical engineering question answers. The superposition theorem is applicable to, so this is asked in the UPPCL JE 2018 paper. The superposition theorem is applicable to linear bilateral network. Okay, so it's applicable to linear bilateral network. It is not applicable to nonlinear networks. Why? Because superposition theorem follows the principle of homogeneity. Okay, we'll discuss right here. A linear element satisfies the property of superposition and homogeneity. Is a standard question. Okay, so answer will be a linear element satisfies the property of superposition and homogeneity. Next one, for a linear networks generally dash analysis is preferred. Okay, so this is asked in the 2014 UPRVU paper. It's a E paper here. For larger network, we'll prefer node analysis. Why? Because with the help of node analysis, the equations and the calculations carried out in the computer will be reduced here, less here. Okay, that's the reason why we'll prefer the nodal analysis. Okay, next one, for DC voltage, inductor behaves as, we know that inductor. Okay, so when the DC current supplied here, the inductor act as a short circuit. Okay, inductor acts as short circuit here. So this asked in the APEPDCL E 2010 paper. Suppose the same question for a DC voltage, capacitor behaves as. Okay, so let's see the next question here. The capacitor behaves as, it's a open circuit, and most of the cases you have seen this is a condition. This is the case here. Okay, when you are applying the DC source here like this, the capacitor behaves as a open circuit. Inductor short circuit, capacitor open circuit here. Next one, what is the number of independent nodes for a network of 10 branches and 4 nodes? Okay, so L is equal to B minus N plus 1, the standard formula, and this is asked in the UPPCL AE 2016 paper. So number of branches are 10 and number of nodes are 4, 4 plus 1. Okay, so which is nothing but 10 minus 4, 6, 6 plus 1, 7. There are 7 independent nodes here. You can call as a L here. The answer will be 1. Next one. Which of the following has the ability to store the energy in the form of electric charge? So this is in SSC JE 18 paper. Okay, electric charge is going to be stored by capacitor. The energy stored by the capacitor is in the form of electric charge, electrostatic energy we can call it. In case of inductor, it is a magnetic energy. So a resistor, what it will do? It will dissipate the energy here. Okay. So answer for this question is 3, capacitor. Next question. For DC voltage, the capacitor behaves as. So just now you have seen the question here. It's a open circuit here. Next one. The power consumed by a pure capacitor is. So power consumed by a pure capacitor is, it is a 0 watts. Okay, so whenever you call a pure capacitor or pure inductor, it is always consumes 0 watts here. So answer will be 4 here. It is asked in the PSNL TTA 2016 paper. Similarly, the power consumed by inductor, sorry, pure inductor, it is also same. So pure inductor also 0 watts only. Okay, next one, the 40th question. If 4 10 microfarad capacitors are connected in parallel, the net capacitance will be. So there are 4 parallel capacitors are like this. So earlier case we have seen the resistor. Okay, so where 10 ohm resistor and 10 resistance are parallel, then it will be result into 1 ohm. But here different case. Okay, if you are looking C equivalent here, and this will be 10 microfarads, 10 microfarads, 10 microfarads, 10 microfarads. Okay, so these are our 10 microfarads or connected in parallel, means the parallel combination will be C equivalent is equal to 10 plus 10 plus 10 plus 10 microfarads, which is equal to 40 microfarads. The answer will be here 2 is the right answer. So this question is asked in SSCJE 2013. Okay, so this next question, the reactance of an inductor is given by. So reactance XL is nothing but omega into L. Okay, which is nothing but omega can be represented as 2 pi F into L here. So this is asked in the HPCL AMT paper 2019 here. The reactance of inductor is given by like this. What about the capacitance? Okay. Next question. The reactance of the capacitor is given by. So XC is equal to 1 by omega into C here. Okay. So the question is wrong here. Omega into C here. Omega into C. So XC is nothing but 1 by omega into C, where omega is nothing but 2 pi F is the answer. Okay. So 42nd question, the answer will be 2 here. Next one. What will be the equivalent inductance of a series combination of 5 inductors having the same value of inductance? So equivalent inductance, there are 5 inductance like this. So L here. So what is L equivalent? So L equivalent is nothing but sum of all the values. So L equivalent is equal to L plus L plus L plus L plus L. So which is equal to 5 into L. So answer is 5L. Next one, inductors stores energy in the form of. So inductor stores energy in the form of magnetic field here. That is about half into L into I square. Okay, this is a basic formula of an energy stored in the inductor here. So which stores energy in the form of magnetic field. Magnetic field here. Okay. So electric field means capacitor. We'll see the next question. Okay. The capacitor stores energy in the form of. So capacitor stores energy in the form of electrostatic field or electric field here. So which is in case of dielectric here. Okay. So where we have capacitive plus plate minus plate capacitance, in between there is a dielectric here, and there we have electric field stored here. So answer will be electric field here. Next one. Resistor dissipates energy in the form of heat. Already we discussed this question. So where I square R into R is a formula. The best example for this question is your water heater. Okay, so when you plug the water heater, what will happen? The heater is going to be heat the water here. So it's having a complete nichrome resistance. Next one, the SI unit of magnetic flux. So flux. Okay, so it is nothing but Weber. We can call it a 10 power 8 lines of force, we can also say. So this is asked in the SSCG 2018 here. Next one, the SI unit of magnetic flux density. So magnetic flux density is nothing but B is nothing but phi by A. So phi is nothing but Webers per area is nothing but meter square. So answer will be Webers per meter square. So that's the answer is 2 here. Next one, the unit of magnetomotive force, we can call as a MMF. Magnetomotive force is nothing but N into I. Okay, so where A is nothing but ampere, N is the number of turns here. So we can call as ampere turns. So answer is 2 here. Okay, so answer is 2. Next one, the coefficient of coupling for a tightly coupled circuits here. So the coefficient of coupling is nothing divided by K. So which is equal to 1 for tightly coupled circuits. Okay, next question. So we covered around 50 questions. One question is repeated now, so I will repeat the one more question here for you. So answer is 1 here. Okay, next one. So all the household appliances are generally connected in. So whatever the household appliances such as a TV or washing machine or fridge, all are connected in parallel here. Okay, and last question for you in this video. Okay, so do you like this video? So you have to give the answer yes or no. Okay, the answer should be given in the comment box here. Okay friends, thank you for watching my video. If you are new to my channel, please subscribe to my channel and share with your friends. Thank you. Have a nice day.